In this video, we'll go over the Curves tab of the Analysis Editor. We'll start with the same example sequence we were using before. I'm going to replace our fundamental template with our THD template. When we open this, we can see a couple things will be different here. The algorithm has changed to harmonic track from heterodyne, and the distortion tab is no longer grayed out. That's because the harmonic track algorithm can produce distortion measurements. Instead of using our templates, you could also use this dropdown to select all available algorithms. Now you can see here if I change back to heterodyne, we no longer have an available distortion tab. Then if I select FFT spectrum, we don't have distortion or electrical, but we do have this frequency tab. Let's take a quick look at the options at the bottom of the editor. You saw apply in the previous video. That will take any changes you made to the editor and apply them in real time. Load will allow you to select a template. Over in the sequence editor, on the left side, all of these step templates are available to select. Instead of dragging them into the sequence, or replacing them as I did earlier, we could open up our analysis step and load one of them. Revert will revert all changes you made since the step was last opened. I'm going to select that now to bring us back to the THD template. Save As will let you save your current configuration as a template. OK will close the step and save the changes. Cancel will close the step without saving your changes. As I was changing between algorithms, we were seeing different items appear in curve names. These curve names are everything that will be output to the memory list when this step is run. On this Curves tab, you can see the fundamental, harmonics, THD normalized, and THD, and on the Values tab, you can see record delay. If I click Apply, it will run our new algorithm and output all of these curves. When I clicked Apply, you could see our fundamental change, but it isn't what we expect it to be. This is something you need to be careful of. If you ever change an analysis step, you need to go back and make sure that the correct waveform response is selected. This is a frequency-based measurement of the impedance waveform, which we don't want. So I'll go back into waveforms and make sure I select the right response waveform. Now let's go back to curves. As was mentioned, everything in curves names is mapped one-to-one to the memory list. If we want to change any of those names, we can do so here. At the top are three checkboxes. Add input data name will automatically append the response waveform name to the curve name. This can be an easy way to keep track of the same measurements done on different stimuli or input paths. Use signal path name will just add the input signal path to the end of the name. This will keep the name shorter if you don't care about the name of the recorded time waveform. The last button will reset the curve names to their default values. That can be helpful because instead of using these checkboxes, you can manually edit these names to whatever you want. Instead of fundamental, say I want to call this response. You can sometimes run into trouble if you go into a sequence and you see a bunch of generic names that you don't know how to interpret. You can go back in, click Use Default, and it goes to the SoundCheck default naming scheme. Let me just redisplay the fundamental so we can take a look at the units. By default, units are based on the input and output signal path used in the analysis step. The input signal path here is reference, so our y-axis is dB/SPL. However, if you need to, this step can output custom units. One common use is to switch from log to linear, or vice versa. Now instead of dB/SPL, this fundamental response is in pascals. This can also be used to completely change the units though. I can highlight this and manually type in whatever I want. For example, this could be measured in volts if I wanted to. We have a dropdown with commonly used dB references that will autofill. So if you select dB/SPL, it will reference 20 micropascals. Again, if you want to, you can manually type in any reference in any unit and SoundCheck will plot it. As a reminder, SoundCheck will not do any calculations based on the unit name you have selected. It will not convert from pascals to volts or pascals to the letter K that I had. It is recommended to not use custom units and leave it as default. However, if your specific application is changing units outside of SoundCheck, you can account for it in here.